things all have in common? Anybody? Right, yes. So that's light. They are all different sources of light. Right? So, what is a light? What do you think? If I ask you what is light, is there anything you think about? Anything you can say or try to answer that question? Energy? Sure. What else? The necessity for life? Good. Okay, anything else? Is it magic? No, no, it's not magic, right? Okay, so if it's not magic, then there were two main ideas about what light is made of. What are these two ideas? Do you know? Have you gone over this or have you heard about this? So there's two ideas about what light is made of. Can you tell me one or the other? Right, so you said first that maybe they are made of waves, right? Or particles, right? You also said that, right? Waves or particles. So light is made of waves or particles. And let's look at the first example, light as a particle. So who came up with the idea of light as a particle? Do you know? Right, our old friend Newton. Right, we've seen him for quite a few times for our lessons. What are the other things we did with Newton? Gravity, and then I think last time, force, right? Is 3 laws, right? Newton's laws. Okay, so Isaac Newton, and then he also did some work on light. So Newton said light is made of tiny particles called corpuscles. Right? Very small particles. And when light hits a mirror, what happens? Do you think you know? What happens when light hits a mirror? Right, it gets reflected, right? Or first, I was going to say, right, it bounces. And then, is this reflection or refraction? Right, you all said reflection. Good. Right, so it's a reflection of light. Okay. Now, how about when it goes into water? Reflection? Oh, it can do both, right? Because we just saw a reflection in water. But it can also bend, right? So that was a little bit confusing on my part, right? So it bends, but it can also reflect. Good. So, is this reflection or refraction? Yes, this is an example of refraction. Okay, now let's look at the other example, light as a wave. So, who came up with the idea of light as a wave? Not as easy as saying Isaac Newton, right? What is his name? Do you know? Christian? Or Christian? Christian, I also don't really exactly know how to pronounce it. I think it's Huygens? Huygens? Or Huygens, if you're like Dutch. Right, so Christian Huygens. And Christian Huygens said light moves like waves on water. Right, and now my hip isn't working. So every point on a wave makes new little waves. This is called Huygens' principle. I'm going to be honest, Oh, no, my gift is not working. Okay, I don't really understand this part completely. Right? I understand what it's supposed to mean, but it's difficult to fully understand what's going on. But all right, this is Huygens' principle. He said light moves more like a wave. And so let's try and look at an example. Why do we look at light as a wave? I see what happened. Okay, yeah, that was supposed to be there. So, what happens when you throw a stone into water? How would you explain this? What happens? Right, oh, yeah. So, it makes waves, right? Or little ripples. Now, you throw two in, you have two sets of waves and ripples. And what happens here? What do you think? What would you say? What happens here? Any ideas? Do they mix? Or, yes, right. So they mix together, and this is supposed to explain interference, right? And this is important because the wave theory explains things like interference and diffraction, right? That particle theory doesn't. Right? So that's why it's important that we have both Isaac Newton's ideas and Christian Huygens' principles. Okay. Good. So that's part one.
Oh, okay. So next, I will introduce the two parts about the reflection law and the refraction law. Okay, in this figure, you can see the light from air to acrylic. And you can see the partial reflection and the partial refraction. If I change the angle of instant light, you can see the refraction angle and the refraction angle is changed. Large and the angle is larger. Okay. We can see the simulation from this one. this simulation, you can change the material. Now I choose the material is air. From air into water. So open the light, you can see the partial reflection and the partial reflection. If I change the angle, the angle is larger. You can see the angle of reflection is larger, and the angle of reflection larger. Try again. Here. Okay? So, do you observe other things? Otherwise, the angle. You can observe the intensity is also changed. When the angle of incident line, the reflection is smaller, the reflection is larger. If the angle is larger, the reflection is larger, and the reflection is smaller. So it's the light instant, the light travel in different media. You can see this finding. So now I want to try change the material. This one is also air, but this one I want to change the solid. I choose acrylic. No, glass. So you can see I change the glass. The partial reflection is the similar, but the reflection something different. And do you find something different? Again. The angle is smaller. So in this simulation, you can see the reflection of angle is decided by the incident line, but the reflection angle is decided by the different material. Different material have different velocity variance. Okay. So back to our worksheet. First, we see the law of reflection. Reflection, this line instant on the surface, and the reflection line here. So we have to draw the normal line is vertical to the surface. You can see the reflection law. One is the reflection line and the incident line, reflection line, and the normal line is on the same surface. This is one. Second one is the angle of incident line, and the angle of the reference angle is the same. So it's the reflection of law. You can draw the import, the key point on your worksheet. Do you find this? The law of reflection have two key points. One is straight line on the same surface. Another is the angle is the same. Okay, next we see the incident line on different surface. You can see if we incident line on the rough surface, the parallel line have different incident angle, and then the refractive angle is changed. So the light will diffraction. The light will from to different direction. This means diffuse reflection. Diffuse reflection. But in these two cases, they all have followed the law of reflection. Okay, next part. Next part is the law of reflection. This law of reflection you have made in junior high, but you have seen this formula. So here I will explain in Chinese. OK， 好，我们已经介绍完反射定律了，所以呢，我接下来要讲折射的部分。好，来，折射定律跟刚刚的反射定律一样，它会有第一条规则，就是我的一个光线，好，它现在穿过不同的介质，那它呢，好，有入射线，然后有折射线，有这一条跟界面垂直的法线，入射线 instant line， 折射线，好 refractive line， 跟这个法线 normal line， 它们三条线必须在 the same plane。要在同一个平面，这是跟反射定律一样的。好，第一条规则在折射定律里面。啊，第二条规则你们就没有看过这个公式了。好，来，第二条规则是什么？你观察一下哦，以这一张图来讲，好，我们的上半部的光走的速度是 v1， 下半部光走的速度是 v2。那以这张图来讲是 v1 的速度大于 v2， 那你看到了什么 ？v1 的速度大于 v2， 那你看到了什么？你看到了它偏折，好，当然有部分反射啦，但我们现在着重在偏折，那么讲折射定律。好，你看到了它是怎样 ？Toward the normal line， 它是偏向法线的，好，它是偏向法线的。所以呢，这一种呢，好，就是属于就是我的速度快到速度慢，角度会变小。好，那这里国中就有这个概念了。那请问一下，数学式子我们怎么表示？好，我们的表示会是这样哦，在这边画一个圆，然后你可以看到呢，哈，它的速度差决定了它的偏折的情形。好，那速度大，一开始角度大，所以它会对到好这个比较长的对边，三角形的对边。那速度小会对到比较小的三角形的对边，所以它会符合这个关系式 ，v1 除以 v2 决定了它的偏折，它会等于 l1 除以 l2。好，this equation is important. Please draw the line at this equation. 那等一下我们的折射定律会从 equation 4至2出发去做推导。好，那在你的讲义上找到这个方程式呢，把它画下来。如果没有看到一模一样的，就自己涂上去啊。好，那再来，那就问同学一个问题了啊，问同学一个问题了。If I change the different medium, V1 is smaller than V2. V1 is smaller than V2. What happened about the refractive line? It's the same, this toward the normal line, or change. V1 is smaller than V2. What happened? If the V1 is smaller than V2, this length L1 is smaller, L2 is larger. So this refractive line will away from the normal line. Away from the normal line. Okay. So this equation is important. 那在我们的那个光学里面有一个定义，哈，刚刚的折射呢是由于速率的变化造成的，所以我们就定义了一个东西，方便大家之后呢，针对不同介质的变化呢，来找它的折射现象。好，那这个东西就叫做折射率，好 ，index of refraction。 好，那我们常用的符号就是 n， 好 ，index of refraction n。好，那 n 的定义一定是跟速度变化有关，所以我们定义 n 等于 c 除以 v。好，请你在讲义上找到，把它画下来。折射率，好 ，index of refraction， 它的定义是 c 除以 v。那等一下我们会从这个 n 等于 c 除以 v 呢来推论。好，在折射里面有一个很有名的 Snell's law， 好，来，那我们看一下常见的这一些介质，它的折射率哈。我们定义的是 vacuum 真空是 n is equal to 1， 好，真空是1。然后呢，空气呢，它的折射率就会是什么？真空中的速度除以空气中的速度。那它出来的值会是 1.003， 1.003代表什么？代表 c 跟 v 差不多。可是呢，空气中的 v 会比 c 再怎样小一些些，好，再小一些些，可以吗？1.0003的意思就是我的空气中的折射率，好，1.0003，那它的速度呢，好，是比真空中的再小一些些的，所以它才会比1大一些些。好，那再来常见的是我们的水，它的折射率是 1.33， 所以这边带进来 1.33， 所以代表水的速度再小一些，好。然后呢，还有我们的玻璃也是常见的。好，那请同学呢帮我把刚刚念下来的这3种介质，它的速度帮我好，就是填在这个表格这边，好，帮我填上去。在这边呢，帮我增加一个栏位，在你的讲义里面，就是在这里，好。来写一下，我写在这里哈。就是呢，这一行是折射率嘛 ，index of refraction 啊。那我们有空气，然后水跟玻璃，啊，这个是常见的。那它的数字已经写了嘛，对不对？好，那我想要你等一下帮我增加一个栏位。帮我把它补上去，请你帮我写上好它的速率 v， 好，帮我补上去。来，第一个要填什么？第一个好要填 c 除以 1.0003， 这个就是我们空气的介质的速率。好，那第二个常见的水。这边就填 c 除以 1.33， 好，再来玻璃就是 c 除以 1.52， 好，所以从这个折射率的定义，其实你可以很清楚知道，好，我的光在里面行走的速度，好，它有什么变化？那这样子我们只要查表就可以清楚知道，好，光速的情形。好 ，OK，so we back to Snell's law。The proof， 好，来，那我们呢，好，把斯奈尔定律，好，从刚刚的equation 4至2呢，我们把这里呢做一下推导，好，来，首先呢，你可以看到这个，它的equation 4至2是 L1， 好，除以 L2， 是由谁来决定？速度。好，那我们现在在Snell's law 里面呢，它的这个公式会跟折射率有关，所以我们要把折射率带进来。好，这里速度，某介质的速率就会是什么 ？c 除以 n1，OK 吗？好，因此呢，第二个速率就会是 c 除以 n2。好，因此这边就可以简化成 n2除以 n1。好，那就会得到我们的 equation 4至4。好，那接着呢，就可以得到我们的 n1 L1 等于 n2 L2。那我们接下来要引入我们的数学的三角函数。好，来，同学应该有些人会有先修过三角函数吧，有些人没有。那我这边简单介绍一下。好。三角函数，好，我们呢会习惯呢，好，把它的边长比用角度 搭配某一个函数呢，把它定义出来。好，那这边呢，同学应该可以很熟悉吧？这个是一个直角三角形，那我的角度是西塔，西塔对面那个边叫对边，西塔旁边这个叫做邻居嘛，就叫邻边。好，然后呢，这个倾斜的最长的就叫斜边。那我们有6个三角函数会在这边做介绍 ，sin 函数、正弦函数、cos 函数、余弦函数、tangent 函数、正切函数，还有它的反三角函数，还有它的那个就是颠倒过来的有 cotangent， 然后呢 secant 跟 cosecant。好，那我们这边只学一个就好了，我们学 sin 函数、正弦函数，因为这边只用到 sin 函数。来 sin 函数呢是什么？ sin 西塔等于好斜边分之对边。好，因此呢，我在这边要引入这个函数了。好，那再回到这里，我们要把这个方程式帮它除以刚刚的图形的半径 r。那么你会发现，这个就是我们的什么 sin 函数，这个就是我们的 sin 函数，好，就是我们的 sin 函数，可以吗？所以你把 L1 除以 r 就会得到 sin 西塔 1，L2 除以 r 就会得到我的 sin 西塔 2，那我们就可以推导出好施耐的定律。Okay, so finally, we can use the concept to try to see the example on the textbook. So everyone, open your textbook on page 110. Page 110. See this example. This problem is saying it's known that the ratio of the speed of light in air to the speed of light in a certain liquid is the root square 3 to 1. If light is instant from the air into the liquid at an angle of instant of 60 degrees， 入射角是60度，好，然后速率比是根号3:1，好。What is the angle of refraction in the liquid？ 所以它是算什么？折射角，好。So you can circle the keyword on your textbook. One is the light, the speed of light. 根号3:1，好。Another is instant angle, 6 degrees. And finally, it gives you the length of 三角形，好，这里。Here. 30 degrees, 60 degrees, 90 degrees. Ratio is 1 to the square root 3 to 2. So from 3 key points, you can get the refraction angle. Refraction angle. 好。So this is the figure to represent the problem. 6 degrees is the instant angle, and we want to solve this refraction angle. How to solve this refraction angle? We need the equation. The equation is here. from the philosophy variance, B1 to B2. So from the first keyword, this is the square root 3 to 1. So from the second keyword, 6 degrees, you can write down the L1. What is the L1? L1 is R. Okay, so from here you can see L2 is 2/R. So from this figure, L2 is 2/R. Here is R. So what is the angle? EB 2:1根号3。好 ，you can draw this shape. R L2 is here. So 2 square root 3. So this angle is 30 degrees. So finally, the answer is 30 degrees. Okay, so today's content is finished. Now we take 5 minutes to do the worksheet on your paper. We have 8 problems. So now, if you haven't finished this worksheet, you can use 5 minutes to finish it. After you finish it, teacher Stephan and I will check the answer. Okay. If you have any problem, you can raise your hand. We will help you. observe 哈。
Okay, let's go through the answers. So, we'll do 1 to 7 together, and then I want to hear your designs for number 8. Okay, number 1. The English scientist, who's the English scientist? Newton, proposed that light consists of tiny particles called what? Corpuscles, right? Which travel in straight lines and can be reflected and can be when they meet a surface. Okay, good. Number 2, the Dutch scientist. Who is the Dutch scientist? Who wants to try? Andrew. You were next. Who is the Dutch scientist? Yeah, oh, very good. You can say it better than me. So, Christian Huygens, proposed that light is a wave phenomenon. According to his principle, every point on a what? Yes, on a wave acts as a source of new waves, forming the what? Next wavefront. And this wave theory explains reflection and refraction. And what are the other two that the particle doesn't explain? Yes? Interference and diffraction, right? Okay, according to the law of reflection, the ray of light approaching the mirror is known as the incident. Okay, good. The ray of light that leaves the mirror is known as the reflective ray. Okay. Number 4, at the point of incidence, where the ray strikes the mirror, a line perpendicular to the surface of the mirror is known as a normal line. The law of reflection states that when a ray of light reflects off a surface, the angle of incidence is equal. Right? Equal to the angle of reflection. Right? Equals. Number 6. When light passes from one medium to another, its speed and direction change. This phenomenon is called, what is this phenomenon called? Refraction, right, refraction. Okay, then, number 7. Please draw a diagram of refraction of a light to show the changing of a light ray's direction when it passes through different matters. Yes. Who wants to volunteer? Come and draw a diagram of refraction. Andrew. Oh, I already picked on Andrew. Oh no, Winston's answered a lot of questions. That's okay. Let's see. Oliver. Yes. You have. You can go draw your example as well. a round of applause for Oliver. Okay. Number 8, design a simple experiment to observe both reflection and refraction using materials you can find at home. So this one you can kind of explain, right? I think you can put it into words. Does anybody have a good example? Kelly? Do you have a good example?
No.
You don't? Let's see. Did you write it? Oh, you didn't get there yet. Okay, who does have an example? Who got to question 8? Let's see. In windows. How? How would the window show reflection and refraction? You see your own reflection in the window? Going through the window. Ah, okay. Is that correct? A window? Oh, so the window, okay, so Ray said the window reflects, you can see your own reflection in the window, and then it refracts the light that goes through the window. Yes? Okay, good. Anybody else? Okay, that's time.